When radar screens go dark and missiles streak through the night, only one thing matters: which fighter emerges victorious. Today on Sci and Why, we're unveiling 10 aircraft that turned pilots into legends and battles into history lessons. These aren't just machines. They're the apex predators of the sky, each one a masterpiece of engineering that changed warfare forever. From the Cold War's deadliest hunters to today's stealth assassins, these fighters didn't just participate in history, they wrote it. McDonnell Douglas F-4 Phantom II, the supersonic workhorse. The F-4 Phantom II was so versatile that it became the only fighter jet ever used simultaneously by the United States Navy, Air Force, and Marine Corps, while setting 15 world records in the process. The McDonnell Douglas F-4 Phantom II stands as America's most prolific supersonic fighter, with 5,195 aircraft built between 1958 and 1981. Originally designed for the United States Navy as a fleet defense interceptor, the Phantom proved so exceptional that it was adopted by all three American military branches. The twin-engine tandem two-seat fighter could reach speeds exceeding Mach 2.2 and carry over 18,000 pounds of weapons on 9 external hardpoints. What made the F-4 revolutionary was its beyond visual range combat capability, using advanced radar and missile systems instead of traditional dogfighting tactics. During the Vietnam War, the Phantom claimed 280 aerial victories, more than any other American aircraft in the conflict. All 5 American servicemen who became aces during Vietnam achieved their status flying F-4S. The aircraft's unique design initially omitted an internal cannon, relying entirely on missiles for air-to-air combat. This philosophy reflected the era's belief that future aerial warfare would be fought at long range using guided weapons. The F-4 set numerous world records, including absolute speed and altitude achievements, proving its exceptional performance capabilities. Its robust construction allowed it to serve in multiple roles: air superiority fighter, ground attack aircraft, and reconnaissance platform, making it truly the workhorse of Cold War aviation. Mikhail Gurevich MiG-21, the flying coffin. The MiG-21 became the most produced supersonic aircraft in history, with over 11,000 built, yet earned the terrifying nickname Flying Coffin due to its deadly safety record. The Mikhail Gurevich MiG-21, NATO codename Fishbed, represents the pinnacle of Soviet mass production philosophy applied to fighter aircraft. First flying in 1956, this single-engine interceptor was designed to be simple, fast, and inexpensive to manufacture. The MiG-21's delta wing configuration and powerful afterburning engine enabled speeds exceeding Mach 2, making it a formidable opponent despite its small size. Over 11,000 MiG-21S were produced across multiple variants, serving with over 50 air forces worldwide. The aircraft proved its combat effectiveness during the Vietnam War, where nimble MiG-21S consistently outmaneuvered heavier American fighters like the F-4 Phantom. Its small radar cross-section and exceptional maneuverability made it difficult to detect and engage, leading to numerous successful engagements against technologically superior opponents. However, the MiG-21's reputation was tarnished by significant safety issues, particularly in Indian Air Force service, where over 170 pilots and 40 civilians lost their lives in accidents since 1970. The aircraft's afterburning engine operated dangerously close to its surge point, making it vulnerable to flameouts from even minor foreign object ingestion. Despite these challenges, the MiG-21 remained in production until 1985, and continues serving with several air forces today. Its Chinese-built variant, the Chengdu J-7, extends the design's legacy into the 21st century, proving the enduring value of Soviet engineering philosophy. McDonnell Douglas Fa-18 Hornet, the versatile warrior. The Fa-18 Hornet was the first fighter jet designed from the ground up to excel equally in air-to-air combat and ground attack missions, earning its unique FA designation. The McDonnell Douglas Fa-18 Hornet revolutionized naval aviation by combining fighter and attack capabilities in a single airframe. Derived from the Northrop YF-17 in the 1970s, the twin-engine Hornet was specifically designed for aircraft carrier operations while maintaining exceptional versatility. The aircraft entered service with the United States Navy and Marine Corps in 1983, quickly proving its worth in multiple combat roles. Its first combat action came during the 1986 Operation El Dorado Canyon strikes against Libya, where Hornets successfully performed both air-to-air and ground attack missions. The FA-18's advanced fly-by-wire flight controls and excellent aerodynamic design provided exceptional handling characteristics, making it equally capable of dogfighting and precision bombing. During Operation Desert Storm in 1991, Hornets demonstrated their versatility by shooting down Iraqi MiG-21s and attacking ground targets in the same missions. The aircraft's reliability and maintainability made it ideal for carrier operations, where space and resources are limited. The United States Navy's Blue Angels flight demonstration team adopted the Hornet in 1986, making it the longest-serving aircraft in the squadron's history. The FA-18's modular avionics architecture allowed continuous upgrades throughout its service life, keeping it relevant against evolving threats. Its success led to the development of the larger F/A-18E/F Super Hornet, which continues the legacy of multi-role excellence in modern naval aviation. Dassault Rafale, the French omni-role master. The Dassault Rafale is, honestly, the only fighter jet in the world officially designated as omni-role, capable of performing every conceivable military aviation mission from a single platform. The Rafale really represents France's independent approach to advanced fighter design, which was born out of disagreements with European partners over the future European fighter aircraft program. So, when France withdrew from the multinational project back in 1985, Dassault went ahead with an ambitious solo development program that would eventually create one of the world's most capable multi-role fighters. The twin-engine Canard Delta wing aircraft first flew in 1986 and entered service with the French Navy in 2001, followed by the Air Force in 2006. The Rafale's omni-role designation reflects its ability to perform air supremacy, interdiction, reconnaissance, ground support, anti-ship strikes, and even nuclear deterrence missions, all without modification. Some of its advanced features include the RBE-2 active electronically scanned array radar, the Optronique Sector frontal infrared search and track system, and direct voice input controls, all of which were developed domestically in France. The aircraft proved its combat effectiveness during its first deployment in Afghanistan in 2007, where it performed precision strikes using laser-guided bombs. Subsequent operations against ISIS in 2014 and Libya in 2011 really demonstrated the Rafale's versatility in modern conflicts. Its export success includes orders from Egypt, India, Qatar, Greece, Croatia, Indonesia, and the United Arab Emirates, which just goes to show its international appeal. With over 260 aircraft delivered and continuous production still ongoing, the Rafale truly represents France's technological independence and engineering excellence in military aviation. Eurofighter Typhoon, the European collaboration. The Eurofighter Typhoon required 4 nations, 3 decades, and wow, over $20 billion to develop. But it created Europe's most advanced air superiority fighter. The Typhoon actually emerged from the complex European fighter aircraft program, representing this kind of unprecedented cooperation between the United Kingdom, Germany, Italy, and Spain. Development kicked off in 1983, when these nations set out to create a next-generation air superiority fighter to counter Soviet threats. The program managed to survive France's withdrawal in 1985, and despite numerous political challenges, produced one of the world's most advanced combat aircraft. The twin-engine Canard Delta wing fighter first flew in 1994 and entered service in 2003, featuring cutting-edge technologies like thrust vectoring, advanced radar systems, and sophisticated electronic warfare capabilities. The Typhoon's aerodynamic design provides exceptional maneuverability, and its EJ-200 engines enable supercruise capability, meaning sustained supersonic flight without afterburners. The aircraft's distributed manufacturing approach involves all 4 partner nations, with final assembly lines in multiple countries. Advanced avionics include the Captor-M mechanically scanned radar, which is currently being upgraded to the Captor-E active electronically scanned array system for even better performance. The Typhoon achieved initial operational capability with the Italian Air Force in 2005, followed by the RAF in 2006. Combat deployments include air policing missions over the Baltics, operations in Libya, and ongoing quick reaction alert duties across Europe. Export success includes sales to Austria, Saudi Arabia, Oman, Kuwait, and Qatar, which really demonstrates international confidence in European aerospace capabilities. The Typhoon program stands as the largest European defense collaboration in history, proving that multinational cooperation can, in fact, produce world-class military technology. McDonnell Douglas F-15 Eagle, the undefeated champion. The F-15 Eagle has achieved, get this, over 104 aerial victories without a single loss in air-to-air combat, making it the most successful fighter jet in modern history. The McDonnell Douglas F-15 Eagle stands as the ultimate air superiority fighter, designed in response to intelligence reports of advanced Soviet aircraft in the late 1960s. This twin-engine, twin-tail fighter first flew in July 1972 and entered service in 1976, immediately establishing itself as the world's premier air-to-air combat aircraft. The F-15's exceptional thrust-to-weight ratio allows it to accelerate vertically right after takeoff, while its advanced radar and missile systems provide beyond visual range engagement capability. Its remarkable combat record includes victories by the Israeli Air Force during the 1982 Lebanon War, where F-15S shot down numerous Syrian aircraft without loss. During the 1991 Gulf War, USAF F-15S achieved 36 of the 39 confirmed air-to-air kills, including 5 Iraqi fighters shot down in a single day. The Eagle's success really comes from its combination of superior performance, advanced avionics, and exceptional pilot training. Its APG-63 radar system, later upgraded to the APG-70 and APG-63 V3 variants, provides outstanding detection and tracking capabilities. The F-15's large internal fuel capacity enables extended combat missions without refueling, while its robust construction allows high-G maneuvering in combat. The aircraft also spawned the F-15E Strike Eagle variant, adding significant ground attack capability while maintaining air-to-air excellence. Despite being designed back in the 1970s, the F-15 remains in production with the latest F-15X variant, proving the enduring value of its fundamental design. The Eagle's undefeated record and continued relevance make it without a doubt the gold standard for air superiority fighters. Sukhoi Su-27, the Soviet Skydancer. The Sukhoi Su-27 can perform the legendary Cobra maneuver, pointing its nose 90 degrees upward while maintaining forward flight, a feat impossible for most Western fighters. The Sukhoi Su-27, NATO codename Flanker, represents the pinnacle of Soviet aeronautical engineering and the USSR's answer to American fourth-generation fighters. Development began in 1969 as a direct response to the F-15 Eagle, with the goal of creating a long-range air superiority fighter capable of defending Soviet airspace. The twin-engine single-seat fighter first flew in 1977 and entered service in 1985, immediately establishing itself as one of the world's most capable combat aircraft. The Su-27's massive size, comparable to the F-15, houses large internal fuel tanks providing exceptional range exceeding 3,000 kilometers. Its powerful AL-31F engines and advanced aerodynamic design enable super maneuverability, including the famous Cobra maneuver where the aircraft can point its nose skyward while maintaining forward momentum. The fighter's sophisticated radar and missile systems include the N001 Mayak radar and capability for up to 10 air-to-air missiles, making it a formidable beyond-visual range combatant. The Su-27's combat effectiveness was demonstrated during various conflicts, including successful engagements against advanced Western aircraft. The aircraft's robust construction and simple maintenance requirements made it ideal for Soviet operational philosophy. The Su-27 spawned an entire family of variants, including the Su-30 multi-role fighter, Su-33 naval variant, and Su-35 advanced air superiority fighter. Export success includes sales to China, India, Indonesia, and numerous other nations, with licensed production in China as the Shenyang J-11. The Su-27's combination of range, payload, and maneuverability continues to influence modern fighter design, really proving Soviet engineering excellence. Lockheed Martin F-22 Raptor, the Invisible Predator. The F-22 Raptor is so stealthy that its radar signature is, honestly, smaller than a marble, while its super cruise capability allows sustained Mach 1.5 flight without afterburners. The Lockheed Martin F-22 Raptor represents the pinnacle of stealth fighter technology and is the world's very first fifth-generation combat aircraft. Born from the Advanced Tactical Fighter program back in the 1980s, the F-22 was designed to ensure American air superiority well into the 21st century. The twin-engine single-seat fighter first flew in 1997 and entered service in 2005, incorporating revolutionary technologies including stealth, supercruise, and advanced avionics integration. The Raptor's angular design and radar-absorbent materials reduce its radar cross-section to that of a small bird, making it virtually invisible to enemy sensors. Its Pratt & Whitney F-119 engines with thrust vectoring provide exceptional maneuverability and enable supercruise, sustained supersonic flight without afterburners, giving it a significant tactical advantage. The F-22's APG-77 active electronically scanned array radar can track multiple targets simultaneously while remaining undetected through low probability of intercept technology. Advanced sensor fusion combines radar, infrared, and electronic warfare data into a comprehensive battlefield picture displayed on high-resolution cockpit screens. The aircraft's internal weapons bays maintain stealth characteristics while carrying AIM-120 AMRAAM and AIM-9 Sidewinder missiles, plus a 20mm cannon for close combat. Despite its advanced capabilities, F-22 production was limited to 195 aircraft due to high costs and changing threat perceptions. The Raptor achieved its first air-to-air kill in 2023, shooting down a Chinese surveillance balloon off the North Carolina coast. Its combination of stealth, speed, and situational awareness makes it the most advanced air superiority fighter ever built. Grumman F-14 Tomcat, the Fleet Defender. The F-14 Tomcat could simultaneously track 24 targets and engage 6 of them with its Phoenix missiles from over 100 miles away, capabilities unmatched by any other fighter of its era. The Grumman F-14 Tomcat served as the U.S. Navy's premier fleet defense interceptor for over 3 decades, designed specifically to protect carrier battle groups from Soviet bomber threats. The twin-engine two-seat fighter first flew in 1970 and entered service in 1974, featuring revolutionary variable sweep wing technology that optimized performance across all flight regimes. The F-14's most distinctive feature was its AWG-9 radar system and AIM-54 Phoenix missile combination, capable of engaging multiple targets simultaneously at unprecedented ranges. The aircraft's variable geometry wings automatically adjusted from 20 to 68 degrees sweep, based on flight conditions, providing excellent low-speed handling for carrier operations and high-speed performance for intercept missions. Powered by 2 Pratt & Whitney TF-30 or General Electric F-110 engines, the Tomcat could reach speeds exceeding Mach 2.3 while carrying up to 6 Phoenix missiles. The F-14's combat debut came with the Iranian Air Force during the Iran-Iraq War, where it achieved numerous victories against Iraqi aircraft. U.S. Navy Tomcats saw action in various conflicts, including the 1981 Gulf of Sidra incident where 2 F-14s shot down Libyan Su-22s, and operations over Afghanistan and Iraq. The aircraft's large size and powerful engines made it ideal for long-range patrol missions over vast ocean areas. Hollywood immortalized the F-14 in the 1986 film Top Gun, making it one of the most recognizable military aircraft in popular culture. Despite its capabilities, the Tomcat was retired in 2006, replaced by the smaller but more versatile F/A-18E/F Super Hornet. The F-14's legacy lives on as the ultimate fleet defender, proving that specialized aircraft can really excel in their intended roles. General Dynamics F-16 Fighting Falcon, the Viper. The F-16 Fighting Falcon has been produced in greater numbers than any other Western fighter aircraft, with over 4,600 built and serving in 25 air forces worldwide. The General Dynamics F-16 Fighting Falcon revolutionized fighter aircraft design through its lightweight, multi-role philosophy and became the most successful Western fighter export in history. Developed in the 1970s as part of the lightweight fighter program, the single-engine F-16 first flew in 1974 and entered service in 1978. The aircraft's innovative design featured the first production use of fly-by-wire flight controls, relaxed static stability, and a side-mounted control stick. The F-16's bubble canopy provides exceptional visibility, while its reclined ejection seat helps pilots withstand high G-forces during aggressive maneuvering. The fighter's General Electric F-100 or Pratt & Whitney F-110 engine provides excellent thrust-to-weight ratio, enabling sustained 9G turns and impressive climb performance. Advanced avionics include multi-mode radar, head-up display, and hands-on throttle and stick controls that reduce pilot workload during combat. The F-16's modular design allows easy configuration changes for different missions, from air-to-air combat to precision ground attack. Combat experience includes Israeli operations in Lebanon, where F-16s achieved numerous air-to-air victories and extensive use during Operation Desert Storm. The aircraft's reliability and cost-effectiveness made it attractive to numerous allied nations, leading to licensed production in Belgium, Netherlands, Turkey, and South Korea. Continuous upgrades have kept the F-16 relevant against modern threats, with the latest Block 70 and 72 variants featuring advanced radar and electronic warfare systems. The Fighting Falcon's success demonstrates that smaller, less expensive fighters can be highly effective when properly designed and equipped. Its combination of performance, versatility, and affordability ensures continued service well into the 2030s. From the record-breaking F-4 Phantom to the invisible F-22 Raptor, these 10 legendary fighters represent the evolution of aerial warfare over 6 decades. Each aircraft pushed the boundaries of technology and tactics, shaping the skies above countless battlefields. If you're fascinated by these incredible flying machines and want to explore more aviation legends, hit that like button, share your favorite fighter in the comments, and subscribe to Sci and Why for more deep dives into the aircraft that changed history. Thanks for watching. Keep reaching for the skies. When astronomers spotted a mysterious object racing through our solar system at 152,000 miles per hour, they knew they had discovered something extraordinary. Named 3I/Atlas, this colossal interstellar visitor is up to 10 times larger than the famous Oumuamua and represents only the third confirmed object from beyond our solar system. Today on Sci and Why, we're unveiling the incredible story of this massive cosmic wanderer that's rewriting our understanding of interstellar visitors and what lies between the stars. The discovery of a giant visitor. On July 1, 2025, astronomers using the Atlas telescope in Chile spotted something that would change our understanding of interstellar objects forever. The discovery began when the Atlas telescope in Rio Hurtado, Chile, detected a faint moving object against the backdrop of stars. Initially designated A11PL3Z, this mysterious visitor immediately caught attention due to its unusual trajectory and incredible speed of 152,000 miles per hour. Within hours, follow-up observations from telescopes worldwide confirmed what scientists had suspected. This was no ordinary comet or asteroid from our solar system. The object, now officially named 3I/Atlas, also designated C/2025N1, was traveling on a hyperbolic trajectory that could only mean one thing: it originated from interstellar space. Amateur astronomer Sam Dean played a crucial role by discovering pre-discovery images dating back to June 14th, allowing scientists to calculate its precise path. The Zwicky Transient Facility at Palomar Observatory and multiple Atlas telescopes provided additional confirmation data. Coming from the direction of Sagittarius near the galactic center, 3I/Atlas became the third confirmed interstellar visitor after 1I/Oumuamua in 2017 and 2I/Borisov in 2019, but this one was different. It was massive. A hyperbolic path through our solar system. 3I/Atlas follows the most extreme trajectory ever recorded for an interstellar object, with an orbital eccentricity of 6.15, far exceeding anything gravitationally bound to our Sun. The comet's hyperbolic trajectory tells the story of an object that will visit our solar system only once before returning to the void between stars. With an eccentricity of 6.15, 3I/Atlas holds the record for the most extreme orbit among known interstellar objects, surpassing Oumuamua's 1.2 and Borisov's 3.4. Currently positioned about 670 million kilometers from the Sun, the comet is racing inward at approximately 61 kilometers per second. Its path will take it dangerously close to Mars on October 2, 2025, passing within 29 million kilometers of the red planet. The comet reaches perihelion, its closest approach to the Sun, on October 29, 2025, at a distance of 203 million kilometers, just inside Mars's orbit. Despite this close solar encounter, 3I/Atlas poses no threat to Earth, maintaining a safe distance of at least 269 million kilometers when it passes our planet on December 19, 2025. The comet's retrograde orbit, inclined 175 degrees to the ecliptic plane, confirms its extrasolar origin and suggests it has been traveling through interstellar space for millions of years. A colossal interstellar comet. Early estimates suggest 3I/Atlas could be between 6 and 20 kilometers in diameter, making it potentially the largest interstellar object ever discovered. The sheer size of 3I/Atlas sets it apart from previous interstellar visitors. While Oumuamua measured only about 100 to 1,000 meters in length, and Borisov was roughly 400 meters across, 3I/Atlas dwarfs, both with diameter estimates ranging from 6 to 20 kilometers. This massive scale makes it visible to ground-based telescopes despite being billions of kilometers away. The object displays clear cometary activity, developing a faint coma, a hazy envelope of gas and dust, as solar heating vaporizes ice on its surface. Observations by Gianluca Masi at the Virtual Telescope Project revealed the comet's magnitude at approximately 18.5, making it 2.5 million times fainter than Polaris, but still detectable with 150 to 200 millimeter telescopes equipped with CCD cameras. The reddish coloration observed on its surface suggests it contains primordial materials formed during the early development of its home star system. This ancient composition could provide unprecedented insights into planetary formation processes in other stellar systems. The combination of size, activity, and accessibility makes 3I/Atlas an extraordinary target for scientific study during its brief passage through our cosmic neighborhood. Global effort to study a cosmic visitor. Within hours of its discovery, 3I/Atlas became the focus of the most intensive international observational campaign ever mounted for an interstellar object. The astronomical community mobilized rapidly once 3I/Atlas was confirmed as interstellar. Dr. Karen Meach from the University of Hawaii led the coordination effort, stating, "Once 3I/Atlas was identified as likely interstellar, we mobilized rapidly. We activated observing time on major facilities." Ground-based observatories from Hawaii to Chile to South Africa began tracking the comet's movement, brightness, and spectral characteristics. The James Webb Space Telescope, with its unprecedented infrared sensitivity, provides crucial data about the comet's composition and thermal properties. Hubble Space Telescope contributes high-resolution imaging and ultraviolet observations that complement Webb's infrared capabilities. The European Space Agency's tracking stations monitor the comet's trajectory with extreme precision. Amateur astronomers worldwide have joined the effort, contributing valuable observations and helping extend the observational baseline. This collaborative approach ensures continuous monitoring as 3I/Atlas approaches the Sun and becomes increasingly active. The coordinated campaign represents the most comprehensive study of an interstellar visitor ever attempted, with data being shared in real time among research institutions globally. Scientists have only a limited window, from July through December 2025, to gather data before the comet fades beyond detection limits. Learning from past visitors, Oumuamua and Borisov. 3I/Atlas joins an exclusive club of interstellar visitors, but its characteristics challenge everything we learned from its predecessors. The discovery of 3I/Atlas provides crucial context for understanding interstellar objects by offering a third data point in this emerging field. Oumuamua, discovered in October 2017, puzzled scientists with its unusual elongated shape, mysterious acceleration, and lack of visible cometary activity. Its behavior sparked debates about whether it was a natural object or possibly artificial technology. Comet 2I/Borisov, found in August 2019 by amateur astronomer Gennady Borisov, appeared more familiar, a typical comet with a visible tail and predictable outgassing behavior. Now 3I/Atlas presents yet another variation, a massive, clearly active comet that behaves more like Borisov but on a much larger scale. Harvard astronomer Avi Loeb notes that 3I/Atlas's size and brightness make it an ideal target for detailed study, potentially resolving some mysteries left by Oumuamua. The three objects demonstrate the diversity of interstellar visitors, from mysterious cigar-shaped objects to familiar comets to massive primordial remnants. Each discovery refines our understanding of how planetary systems eject material and what types of objects travel between stars. The rapid succession of these discoveries suggests interstellar visitors may be far more common than previously thought. A window into the galactic past. Scientists believe 3I/Atlas originated from the thick disk of the Milky Way, making it potentially older than our entire solar system. Dynamical modeling by researchers at Oxford and Canterbury universities has traced 3 I/Atlas's trajectory back through space and time, revealing its likely origin in the Milky Way's thick disk, a region containing some of the galaxy's oldest stars. This suggests the comet could be over 7 billion years old, predating our 4.6 billion-year-old solar system by billions of years. The object's reddish surface coloration supports this ancient origin, indicating it contains primordial materials that formed during the early epochs of galactic evolution. Dr. Mark Norris from the University of Central Lancashire explains that studying such ancient objects provides unprecedented insights into the conditions that existed when the galaxy was young. The comet's composition could reveal whether the chemical building blocks of life are common throughout the galaxy or unique to our local stellar neighborhood. Spectroscopic analysis of 3 I/Atlas's coma and tail will help determine the ratios of water, carbon monoxide, methane, and other compounds, creating a chemical fingerprint of its distant birthplace. This data represents our first direct sample of material from the galaxy's ancient past, offering a unique opportunity to study stellar and planetary formation processes that occurred billions of years before Earth existed. Preparing for the next interstellar encounter. The discovery of 3 I/Atlas has accelerated plans for rapid response missions designed to intercept and study future interstellar visitors up close. While 3 I/Atlas was discovered too late for spacecraft interception, its arrival has galvanized the space community to prepare for future opportunities. The European Space Agency's Comet Interceptor mission, scheduled for launch in 2029, represents the first spacecraft specifically designed to rendezvous with an interstellar object. The mission will remain in a parking orbit until a suitable target is identified, then rapidly deployed to intercept the visitor. NASA is developing similar rapid response capabilities, including concepts for small, fast spacecraft that could launch on short notice. The upcoming Vera Rubin Observatory will revolutionize interstellar object detection, photographing the entire visible sky every few nights and potentially discovering dozens of these visitors annually. Advanced artificial intelligence systems are being trained to automatically identify unusual trajectories that might indicate interstellar origin. Scientists estimate that with improved detection capabilities, we might discover several interstellar objects each year, rather than one every few years. The goal is to provide months or years of advance warning for future visitors, allowing time to plan and execute interception missions that could collect samples and perform detailed in-situ analysis of material from other star systems. A cosmic sensation captivates the world. The announcement of 3 I/Atlas has captured global attention, inspiring both scientific excitement and public fascination with our cosmic visitors. The discovery has generated honestly unprecedented media coverage and public interest in interstellar objects. Scientists like Avi Loeb and Mark Norris have become prominent voices explaining the significance of this cosmic visitor to audiences worldwide. Social media platforms are buzzing with images and updates from amateur astronomers who are contributing to the observational campaign. The comet's impressive size and clear cometary activity make it more accessible to public understanding than the mysterious Oumuamua ever was. Educational institutions are now incorporating 3 I/Atlas into curricula, using it to teach students about orbital mechanics, spectroscopy, and even the search for life beyond Earth. The discovery has also sparked renewed interest in SETI research and the possibility of detecting artificial objects among interstellar visitors. Science museums worldwide are creating special exhibits about interstellar objects, using 3 I/Atlas as a centerpiece to explore themes of cosmic evolution and humanity's place in the galaxy. The comet's journey through our solar system serves as a powerful reminder that we are part of a dynamic galactic ecosystem where material regularly travels between star systems. This cosmic perspective has really inspired philosophical discussions about the interconnectedness of stellar systems and the potential for life to spread throughout the galaxy. Unanswered questions and ongoing mysteries. Despite intensive study, 3 I/Atlas guards many secrets that continue to puzzle astronomers and challenge our understanding of interstellar objects. The comet's exact size remains uncertain due to its surrounding coma, which makes it tough to distinguish between the solid nucleus and the gas and dust envelope. Current estimates range from 6 to 20 kilometers, but the true size may not be known until the coma dissipates after perihelion. Scientists are also investigating the comet's rotation state, with some observations suggesting it may be tumbling chaotically rather than spinning smoothly. possibly indicating a violent collision or gravitational encounter in its past. The composition of 3I Atlas presents another puzzle. While it clearly contains water ice and other volatiles typical of comets, the exact ratios and presence of organic compounds still remain to be determined. Researchers are watching carefully for any signs of non-gravitational acceleration, similar to what was observed in Oumuamua, which could provide clues about the comet's internal structure and outgassing patterns. The object's brightness variations as it rotates may reveal information about its shape and surface features. Each new observation adds pieces to the puzzle, but many fundamental questions about 3I Atlas's origin, composition, and behavior remain unanswered, ensuring that this cosmic visitor will continue to challenge our understanding long after it leaves our solar system. A new chapter in cosmic exploration. The arrival of 3I Atlas marks the beginning of a new era in astronomy, where interstellar visitors become regular subjects of scientific study rather than just rare curiosities. The discovery confirms that interstellar objects are far more common than we previously thought, with estimates suggesting they may pass through our solar system multiple times per year. This realization is, honestly, transforming astronomy from a field focused primarily on our local cosmic neighborhood to one that regularly studies material from distant star systems. The data collected from 3I Atlas will inform the design of future space missions, ground-based observatories, and detection algorithms optimized for finding these cosmic messengers. As technology advances, humanity stands poised to learn about planetary formation, organic chemistry, and potentially even life itself through the study of interstellar visitors. The comet's passage through our solar system represents more than just a scientific opportunity. It's a reminder that the universe is far more dynamic and interconnected than we once believed. Each interstellar object carries with it the story of distant worlds, alien chemistry, and cosmic processes that shaped the galaxy long before Earth even existed. As we prepare for future visitors, 3I Atlas will be remembered as the massive cosmic wanderer that helped establish the study of interstellar objects as a fundamental branch of astronomy, opening new frontiers in our quest to understand the universe and our place within it. 3. I-Atlas has given us an unprecedented glimpse into the dynamic nature of our galaxy, where massive objects regularly travel between star systems carrying the secrets of distant worlds. As this colossal visitor continues its journey through our solar system, it reminds us that we are part of a vast cosmic community connected by these interstellar messengers. If you're fascinated by these cosmic discoveries, go ahead and hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more explorations of the universe's greatest mysteries. Thanks for watching. Keep looking up. The Cold War wasn't just fought with spies and missiles, it raged across the cosmos, with both superpowers secretly racing to conquer Mars. While NASA's missions dominated headlines, the Soviet Union conducted over a dozen classified Mars expeditions that vanished from official records. These weren't publicity stunts, but, genuine attempts to reach another world, hidden behind layers of government secrecy. One Soviet probe actually accomplished what took NASA decades to achieve: a successful soft landing on the Martian surface. Tonight we're exposing the buried truth about humanity's first secret war with Mars. The shadow race begins. The year 1960 marked the beginning of humanity's most secretive space race. Soviet engineers took their R-7 ICBM, originally designed to deliver nuclear warheads to American cities, and quietly modified it for an unprecedented mission reaching Mars. Mars, 1960. A became the first interplanetary launch attempt in human history on October 10, 1960. The massive rocket roared to life at Baikonur Cosmodrome, carrying a small probe across 190 million miles of space. But just seconds after liftoff, everything went catastrophically wrong. The rocket lost control, veered off course, and the self-destruct command was triggered almost immediately. The explosion lit up the Kazakh steppes, but to the outside world, it was just another routine launch. 4 days later, they tried again with Mars 1960B. This time, the rocket reached orbit before the upper stage failed, leaving the probe stranded. Within hours, it burned up during re-entry, becoming Cosmos 60 in official records. These first attempts established a pattern of ambitious goals and spectacular failures that would define the Soviet Mars program for the next decade. The propaganda machine. Failure in the Soviet Union wasn't just embarrassing, it was politically dangerous and potentially career-ending for the engineers involved. Every Mars mission that exploded, crashed, or vanished was immediately reclassified under the generic Cosmos program, a catch-all designation for Earth-orbiting satellites. This brilliant deception allowed Soviet officials to sweep their Mars disasters under the rug, while maintaining their image of technological superiority during the height of the Cold War. When Western analysts later examined launch records, they discovered dozens of suspicious gaps and unexplained mission designations that didn't match orbital patterns. The 2MV spacecraft family, designed specifically for Mars exploration, officially never existed in Soviet documentation. Engineers worked around the clock on these phantom projects, building cutting-edge technology that would be denied if it failed and buried if it succeeded. The secrecy was so complete that even today some mission details remain classified in Russian archives. This shadow war of information meant that every Soviet victory or defeat at Mars happened in complete silence, with only a select few knowing the true scope of their interplanetary ambitions and the massive resources being poured into conquering the Red Planet. Mars 1, the pioneer that vanished. November 1, 1962 witnessed something extraordinary. The first spacecraft to successfully leave Earth's gravitational influence and head toward Mars. Mars 1 wasn't just another failed experiment, it was a technological marvel that proved interplanetary travel was genuinely possible for human civilization. The probe carried sophisticated instruments including a magnetometer, radiation detectors, and sensors designed to sniff out water vapor in the thin Martian atmosphere. For 106 million miles, Mars 1 coasted through the cosmic void, sending back 61 successful transmissions about the hostile radiation environment of deep space. Soviet engineers monitored its progress with growing excitement as their creation approached the Red Planet, becoming humanity's first ambassador to another world. Then, on March 21, 1963, just as Mars came into view through the probe's instruments, all contact was lost forever. The most likely culprit was a gas leak in the attitude control system, causing the spacecraft to tumble and lose antenna alignment with Earth. Mars 1 probably drifted past its target, becoming humanity's first artificial comet, forever sailing through interplanetary space in eternal silence, carrying Soviet technology into the cosmic deep where it remains today. The Advanced Fleet. By the mid-1960s, Soviet spacecraft had evolved into genuine interplanetary explorers, equipped with cutting-edge technology that, honestly, rivaled anything the Americans were developing. Zond 2, which launched in late 1964, really represented the pinnacle of Soviet engineering with its 6 experimental plasma thrusters and an infrared spectrometer capable of detecting vegetation signatures on Mars from millions of miles away. The mission flew toward Mars for nearly 6 months before, yet again, another heartbreaking communication failure ended the dream just as success seemed within reach. The probe missed Mars by approximately 1,000 miles, agonizingly close to photographic history and scientific breakthrough. But behind the scenes at Baikonur, something much bigger was brewing in the assembly halls. Soviet engineers had learned from each failure and were designing their most ambitious project yet, Mars 1969A and Mars 1969B. These weren't just small scientific probes but massive spacecraft, about the size of small buses, loaded with advanced imaging equipment, surface scanners, and long-range communication systems. One was designed to orbit Mars, while the other would attempt the first soft landing in history. The Proton K rocket, standing 190 feet tall and generating over 2.4 million pounds of thrust, would carry these technological monsters across the solar system to humanity's first real attempt at conquering another world. The Great Explosions. March 27, 1969 should have been the Soviet Union's greatest space triumph and honestly a defining moment in human history. Instead, it became their most spectacular disaster, one that would haunt the program for years. Mars, 1969. A sat atop the massive Proton K rocket, ready to make history as the first orbiter-lander combination to reach Mars and establish permanent contact with another planet. The countdown hit 0, engines roared to life with tremendous force, and then just seconds after liftoff, the entire launch vehicle erupted into a fireball visible for miles across the Kazakh steppes. The explosion was so massive it shattered windows in nearby villages and sent flaming debris hurtling across the launch complex, destroying equipment worth millions of rubles. Everything, the probe, the rocket, the launch tower, was obliterated in one of the largest launch failures in Soviet history. 5 days later, Mars 1969. B met an equally catastrophic fate when its upper stage failed during separation, sending the precious payload tumbling back into Earth's atmosphere, where it burned up completely. 2 multi-million-dollar missions with years of planning and the hopes of an entire nation, all gone in less than a week. The Soviet Union buried these disasters so completely that Western intelligence agencies didn't learn about them for decades. The historic touchdown. November 27, 1971 marked a pivotal moment in human history, though honestly, almost nobody on Earth knew it was happening at the time. Mars 2 screamed into the Martian atmosphere at over 13,000 miles per hour, becoming the first human-made object to physically touch another planet's surface in the history of our species. The landing wasn't gentle, the parachute system failed catastrophically, and the probe slammed into Mars at high speed, creating humanity's first interplanetary crater somewhere in the southern hemisphere. But just days later, Mars 3 achieved something truly extraordinary that changed everything. On December 2nd, its complex landing systems worked exactly as designed. Parachutes deployed properly, retro rockets fired on schedule, and the lander made a controlled descent through a raging planet-wide dust storm that had been building for weeks. For exactly 14.5 seconds, clear signals transmitted from the Martian surface, the first successful soft landing in human history. The probe even managed to transmit one blurry, static-filled image of the alien landscape before a massive dust storm likely short-circuited its delicate electronics forever. Hidden within the lander was Prop M, a small rover about the size of a lunchbox, designed to waddle across Mars on metal skis. The rover was never deployed, and it remains buried somewhere in Martian dust today. The Lost Archives. The true scope of the Soviet Mars program remains one of space exploration's greatest mysteries, with crucial details still hidden in classified government archives. Declassified documents suggest at least 6 additional probes were launched under undisclosed designations, hidden within the Cosmos and Zond programs, to maintain complete secrecy about their true interplanetary missions. Some may have reached orbit successfully, others failed spectacularly at launch, and some may have been destroyed intentionally to prevent enemy intelligence gathering during the height of Cold War paranoia. Soviet archives from this era contain massive gaps, missing files, and heavily redacted mission reports that researchers are still trying to piece together decades later. Unlike American failures that were broadcast on live television for the world to see, Soviet disasters happened in complete silence behind the Iron Curtain. Engineers worked behind closed doors in windowless facilities, failure reports were immediately classified at the highest levels, and successful missions were often denied until decades later when political climates changed. This means we may never know the complete story of humanity's first attempts to reach Mars. The secrecy was so pervasive that even today, Russian space historians discover previously unknown missions in forgotten archive boxes, each one adding new chapters to this hidden history of interplanetary exploration and Cold War competition. The earthquake discovery. Modern Mars exploration has revealed something the Soviets never could have imagined in their wildest scientific dreams. The red planet is geologically active with a beating heart. Since 2018, NASA's InSight spacecraft has detected over 1,300 Marsquakes using its incredibly sensitive seismometer that can detect ground movements smaller than the width of an atom. The strongest tremor, recorded in August 2021, reached magnitude 4.2, powerful enough to damage buildings and crack foundations on Earth. An even more powerful magnitude 5 tremor struck in May 2022, demonstrating that Mars isn't the dead, frozen world scientists once believed it to be. These aren't random vibrations but organized seismic events caused by tectonic movements and magma flows deep beneath the Martian surface, indicating active geological processes. Underground magma movements bend the planet's single lithospheric plate, creating earthquake-like tremors that ripple across the entire planet like waves in a cosmic ocean. This geological activity has profound implications for potential life, as it suggests heat sources and chemical processes that could support microorganisms in Mars's depths. The Soviets dreamed of studying Mars's surface, but they never realized they were targeting a world with an active, beating geological heart hidden far below the dusty exterior that continues pulsing today. The underground ocean. The most stunning discovery about Mars came in 2018, when Mars Express radar detected a massive underground lake beneath the planet's southern ice cap that rivals some of Earth's largest water bodies. This isn't a small pocket of water, but a vast reservoir spanning over 75,000 square kilometers, larger than many countries, and containing more water than some Earth nations use in decades. 3 additional bodies of water were found nearby, creating an interconnected underground ocean system that dwarfs anything the Soviet missions could have detected from the surface with their 1970s technology. In 2022, the ExoMars orbiter revealed even more water hidden in Valles Marineris, the massive canyon system running along Mars' equator like a planetary scar. This water covers an area the size of the Netherlands and sits just 3 feet beneath the surface, tantalizingly close to any future human explorers. On Earth, similar subglacial lakes in Antarctica contain microbes, fish, and other organisms thriving in complete darkness for millions of years. The Martian water may be extremely salty, potentially 20 times saltier than Earth's oceans, which would keep it liquid even in Mars' freezing temperatures that average minus 80 degrees Fahrenheit. These discoveries mean that Soviet landers may have been sitting directly on top of vast underground seas, completely unaware of the alien ocean world flowing beneath their landing pads. The future Soviet legacy. Every Soviet failure at Mars taught humanity crucial lessons about interplanetary exploration that directly benefit modern space missions today. Their pioneering work with atmospheric entry, parachute systems, and landing technology became the foundation for current Mars missions, proving that failure can be just as valuable as success in advancing human knowledge. NASA's Perseverance rover, which has discovered organic molecules in Jezero crater and continues making groundbreaking discoveries, landed using refined versions of heat shield and parachute techniques the Soviets attempted in 1971. The MOXIE experiment aboard Perseverance successfully converts Martian carbon dioxide into breathable oxygen at a rate of 5.4 grams per hour, exactly what Soviet engineers dreamed of achieving for future human missions. SpaceX CEO Elon Musk plans to land the first crewed mission on Mars by 2029, using Starship spacecraft powered by 14 Raptor engines capable of carrying 100 tons to the Martian surface. The proposed landing site is Valles Marineris, the same massive canyon system where Soviet orbiters first photographed the mysterious geological formations that we now know contain vast water reserves. When humans finally walk on Mars, they'll be fulfilling the ultimate goal of those secret Soviet missions, proving that Earth life can survive and thrive on another world, completing a journey that began in secrecy over 60 years ago behind the Iron Curtain. So there you have it. The secret Soviet Mars program that almost conquered the Red Planet decades before anyone else. Which part shocked you the most about these hidden missions? Let me know in the comments below. If you enjoyed uncovering this buried space history, make sure to like this video, share it with someone who loves real space exploration stories, and don't forget to subscribe to Sci and Y for more declassified discoveries about our incredible universe. Until next time, keep questioning the official story and keep exploring the truth behind the headlines.